Hello everyone. In this video, we are going to solve the problem number 1.52 from Irodov, and that is related to kinematics. So let us first understand the problem and then we will solve the problem step by step. A point A is located on the rim of a wheel of radius r is equal to 0.5 meter, which rolls without slipping along a horizontal surface with velocity of 1 meter per second. So let us say we are having the wheel which is rolling on the surface with the velocity of v is equal to 1 meter per second, and it is also rotating with the angular velocity of, let us say, omega. The radius of the wheel is given as 0.5 meter and it is rolling without slipping. Let us first understand the meaning of this. For example, at the bottommost point, we will have the velocity in this direction due to the translational motion, and due to the rotational motion, we will have the velocity in this particular direction, that is v is equal to omega into r. Now let us consider the coordinate system, that is x and y axis. So at the bottommost point we can have the three different conditions. First condition will be velocity greater than omega r, second condition will be velocity less than omega r, and third condition will be velocity is equal to omega r. Now let us first talk about first condition. In the first condition, let us say we are having the car which is moving with the velocity of v, and it is also rotating with omega. The wheel is rotating with omega, and in this particular case at the bottommost point initially we are having velocity is equal to omega r. Now at the time moment of t you have applied the brake. Because of applying the brake, what you are doing, you are trying to reduce the omega, but at that time instant the velocity is same as the previous one, so your omega has reduced. Because of that, now velocity is greater than omega r. This is the condition of skidding. Okay, when you are having the velocity more than the angular velocity, more than the velocity due to the rotation. Now talking about the second condition, let us say your car is in the mud surface. Okay, and because of that you are trying to move with a certain velocity of v, and as you are accelerating, because of that you are increasing the omega. But there is not enough friction between the surface of the wheel and the mud surface, so that it is not able to produce that much velocity. So in this particular case the velocity will be less than omega r. We call this is the condition of the slipping. Now take the another third case, that is v is equal to omega r. In this particular case, this velocity and this velocity both are same, so momentarily this point will be at rest. This is the condition of pure rolling, okay, where v is equal to omega r. Now let us come to our problem, in which we have to find the modulus and the direction of the acceleration vector of point A. Okay, so in the A part, let us say this is the wheel, and for example the point A is at this particular point and it is making an angle of, let us say, theta, and it is rolling in this particular surface. Okay, now if we talk about the velocity at this particular point, it is having the velocity in this x direction due to the translational motion, and due to the rotational motion we are having the velocity in this direction, that is v is equal to omega r, and both are same. So here also we will have the velocity of 1 meter per second, and this particular angle is theta, so this angle will also be theta. Now we can write the component of velocity in the x and y direction. So we can say velocity in the x direction is v plus v into cos theta, that is v times 1 plus cos theta, and in the y direction we can write the velocity as minus v into sin theta, because the component of this velocity is in the negative y direction here. So if we want to write the acceleration in the x and y direction, that we can write it as ax is equal to dvx upon dt is equal to velocity differentiation of 1 is 0 and the differentiation of cos theta is minus sin theta and the differentiation of theta is d theta upon dt. And ay we can write it as d of vy upon dt, that is equal to minus v times, and the differentiation of sin theta is cos theta into d theta upon dt. We can, as it is moving with the angular velocity of omega, we can write omega is equal to d theta upon dt. So from here we will get minus v omega sin theta, and here we will get minus v omega cos theta. Okay, v is equal to omega r is given as 1 meter per second, and here we know the value of r is 0.5 meter, so we will get omega is equal to 2 radian per second. Okay, so this is the value of omega we got, and that acceleration vector we can write it as minus v omega sin theta I cap minus v omega cos theta j cap. Okay, and if we want to find the modulus of the acceleration, that we can write it as minus v omega sin theta whole square plus minus v omega cos theta whole square under root, because both are mutually perpendicular to each other. So from here we will get v omega times sin square theta plus cos square theta under root. So sin square theta plus cos square theta is 1, so we will get v into omega, and v is 1 meter per second and omega is 2 radian per second, so we will get 2 meter per second square. So this is the value of net acceleration we got, 2 meter per second square of the point A. Now let us talk about the second part of the problem. In the second part, it is asking to find the total distance as traversed by the point A between the two successive moments at which it touches the surface. So let us say at the time instant of t is equal to 0, point A was touching the surface. Point A was touching the surface. Let us say this is point A, and at the time instant of t, the wheel has moved by the certain angle, let us say theta. So the wheel has moved by the angle of theta and it has reached to this particular point, and this angle is theta. Okay, now we have to determine the distance traversed by this point A in a single rotation, because it is saying that when the A is again touching the surface. So in one rotation the A will again come to this particular point, and it is the two successive time instant in which the point A is touching the surface. Now at this particular time instant we are having the velocity due to translational motion in this direction, and due to rotational motion we will have the velocity in this direction, that is equal to omega r. Now this is the angle here, so this will be the angle theta. So the angle between these two velocity we will get it as pi minus theta. Okay, so if we write the resultant velocity is equal to velocity square plus v square plus 2v square into cos of pi minus theta under root. So from here we will get 2v square minus 2v square into cos theta under root. So from here we will get 2v square as a common, 1 minus cos theta under root, and we can write cos theta as 1 minus 2 sine square theta by 2, and if we substitute the value of cos theta here, so we will get 2v square times into 2 times sine square theta by 2 under root. So from here we will get 2v into sine theta by 2 mod. Okay, now let us find out the distance from the v resultant. V resultant we can write it as ds upon dt, that is equal to 2v, and let us consider sine theta by 2 as positive, so we can get 2v sine theta by 2. Let us take dt to this particular side, so we will get ds is equal to 2v sine theta by 2 into dt. We cannot integrate because here we have to integrate with respect to time, and but here theta we are having as the different variable, so we have to substitute theta as a function of time. So we can write theta is equal to omega into t, or we can also write here as t is equal to theta upon omega, and we can replace dt with d theta. So let us differentiate this particular time. So we will get dt is equal to d theta upon omega. So from here we can write ds is equal to 2v sine of theta by 2 into d theta upon omega. Let us integrate both the sides from s is equal to 0 to s and theta is equal to 0 to 2 pi. Okay, so from here we got 2v into 2 by omega into the integration of sine theta by 2 is minus cos of theta by 2 minus cos of theta by 2, from theta is equal to 0 to 2 pi. So we will get 4v upon omega times minus cos of pi plus cos of 0, and cos of pi is minus 1 and cos of 0 is 1, so we will get 8v upon omega, and omega is 2 radian per second, so from here we will get 8 into 1 whole divided by omega is 2, that is 4 meter. Okay, so this is the value of distance we got, and here we got the value of the total acceleration of point A. So I hope the entire procedure is clear. Thank you.